This question was asked in TIFR 2020 Integrated PhD Part B, and we need to solve this integral. And let me tell you that I am getting the second option, and how I got this answer, let me explain. So this was the integral. Let me call the integral to be I, and this is minus pi over 2 to pi over 2 dx cosine hyperbolic k x square sine square x dx, and this can be written as 1 over 2 minus pi over 2 to pi over 2 and dx cosine hyperbolic x square and 1 minus cos 2x, and this can be clearly written as 1 over 2 minus pi over 2 to pi over 2 dx cosine hyperbolic kx square and minus 1 over 2 minus pi by 2 to pi by 2 dx cosine hyperbolic kx square cos 2x. Let me call this integral I1 and this integral to be I2. So I will be equals to I1 minus I2. Let us calculate I1 first. I1 is equals to 1 over 2 minus pi by 2 to pi by 2 cosine hyperbolic kx square dx, and after the integral we will get sine hyperbolic kx square divided by 2kx. Limit is from pi by 2 to pi by 2, so this will be equals to 1 over 4k and if we put the limit we will get sine hyperbolic k pi square by 4 over pi by 2 minus will be plus sine hyperbolic k pi square by 4 divided by pi by 2. So this will be equals to 1 over k pi sine hyperbolic k pi square by 4, and this can be written as 1 over k pi e to the k pi square by 4 minus e to the minus k pi square by 4 over 2, and in the large k limit our e to the minus k pi square by 4 tending to 0. So I1 turns out to be 1 over 2k pi e to the k pi square by 4. So this is our I1, and let us calculate the I2 now. So I2 will be equals to 1 over 2 minus pi by 2 to pi by 2 dx cosine hyperbolic kx square and cos 2x, and let us do this integral by product rule. Let us say this is first and this function to be second, and this will be equals to 1 over 2 cosine 2x, and the integration of cosine hyperbolic kx square is again sine hyperbolic kx square divided by 2kx minus the differentiation of cos 2x is minus 2 sine 2x and sine hyperbolic kx square divided by 2kx, and the limit is from minus pi by 2 to pi by 2. So let us split this integration. We will get 1 over 4k and cos 2x sine hyperbolic kx square divided by x minus pi by 2 to pi by 2 plus 1 over 2k minus pi by 2 to pi by 2 sine 2x over x sine hyperbolic kx square. So let us calculate this first, and this will be equals to 1 over 4k and if you put the limit we will get cos pi sine hyperbolic k pi square by 4 over pi by 2, and minus minus will be plus, minus minus will be plus, yes, cos minus pi and sine hyperbolic k pi square by 4 over pi by 2, and this will be equals to 1 over pi k, and cos pi is minus 1, cos minus pi is also minus 1, so this will be minus 1 over pi k sine hyperbolic k pi square by 4. And in the large k limit, this sine hyperbolic k pi square by 4 will be again e to the k pi square by 4 divided by 2, as we have done in the I1 case. So it will be minus 1 over 2 pi k e to the k pi square by 4. So our I2 will be minus 1 over 2 pi k e to the k pi square by 4, and the remaining part was 1 over 2k limit minus pi by 2 to pi by 2 sine pi x sine pi x or sine 2x, sorry, sine 2x by x, and let me check what was this, sine hyperbolic kx square dx. So putting this all together we will get I is equals to I1 minus I2, and this will be equals to 1 over 2 pi k e to the k pi square by 4, minus minus will be plus here, so this will be minus plus 1 over 2 pi k e to the k pi square by 4, and minus 1 over 2k minus pi by 2 to pi by 2 sine 2x by x sine hyperbolic kx square dx. So this will be equals to 1 over pi k e to the k pi square by 4 and minus 1 over 2k minus pi by 2 to pi by 2 sine 2x by x sine hyperbolic kx square dx. And if we do this integral we will get the term proportional to 1 over k, and 1 over k is already there, so we will get the term containing 1 over k square. So let me do this for you one more time. So let us calculate this integral, minus pi by 2 to pi by 2 sine 2x over x sine hyperbolic kx square dx. Let us use the product rule once again. So this will be equals to, this function is first, this is second, so this is sine 2x over x. The integration of this is cosine hyperbolic kx square by 2kx, and minus integration minus pi by 2 to pi by 2. The differentiation of sine 2x over x is 1 over x as it is. Sine 2x integration will be minus cos 2x divided by 2 and minus 1 over x square and sine 2x, and this is cosine hyperbolic kx square by 2kx. And if we put the limit minus pi by 2 to pi by 2, this will be 0, so there will not be the term, this term. And if we evaluate this term, this will be of the order of 1 over k square, by the way. And outside this integral 1 over k sitting there. So if we solve this integral, this turns out to be the order of 1 over k cube, and in the limit of large k, this has to be very small. So I think in the large k limit, this integral should converge to 1 over pi k e to the k pi square by 4. Once again, I'm not sure this answer is correct, but most probably this answer should be the correct one. So please write down your valuable suggestions in the comment section, and just wait for the final answer sheet to come. Thank you very much.